All right. So we can calculate the derivative of any function using the kind of processes that we were talking about today. And to show you that that's actually true, let's find the derivative of this weird function.
Okay.
All right.
Yeah, and so, I'm gonna write this down. I'm gonna take notes on this just as an example.
Y equals x to the x.
Yeah.
Okay. We could do the same thing to each side, and it wouldn't change the equation, right? It'd be the same.
Yeah.
So I could take the natural logarithm of both sides.
ln of both sides. Yeah.
And it's the same equation, same thing. Because we've done the same thing to each side.
Yeah.
All right. So log rules tell us I can bring the x from the top to the bottom.
Yep.
Right? ln y equals x ln x.
Yeah.
Now, if I want to find the derivative of this, I can use implicit differentiation. I'll just take the derivative with respect to x of both sides. We cool with that?
Yeah.
So if we want to find the derivative of the left side, we have to take the derivative of ln y with respect to y, which is 1 over y. Right?
Wait, say it again?
If we want to take the derivative with respect to x of ln y, we first have to take the derivative.
The ln of x would be just 1 over x.
Yep, so ln y with respect to y is 1 over y.
Yeah.
Okay. Then we have to multiply it by the derivative of y with respect to x. That's what the chain rule tells us.
Mm-hmm.
Cool. Then we'll take the derivative of this side, which is easier. It's just the product rule, right? We take x times the derivative of the second function and plus the second function times the derivative of the first function, which is just 1. So here we use the chain rule. Here we use the product rule.
Okay.
Cool with that?
I'm cool with that.
Cool. What do you notice about x times 1 over x?
That's just 1.
Yeah, exactly. All right.
Mm-hmm.
Cool. So I'll clear it and I'll rewrite what we have. 1 over y times dy over dx equals 1 plus the natural logarithm of x.
Yep.
But y equals x to the x, right? That's what we said at the beginning.
Yeah.
So I can replace y with x to the x.
Okay. 1 over x to the x?
Yeah, because 1 over y and y is x to the x, so it's 1 over x to the x.
Yep.
All right. Let me get my eraser tool. All right. Equals 1 plus ln x. All right. If I multiply both sides by x to the x, right, this becomes 1, so it goes away. And then we get dy over dx equals, if we multiply this by x to the x, we get x to the x plus x to the x times ln x.
Sorry, okay, wait, I think I missed that step.
That's okay.
Just from...
Yeah, I did multiple steps at once. So we had 1, here, maybe I should just erase this so I can rewrite it so there's not a cross in the middle. All right, so you agree with this equation, the one in the middle, right?
Yeah.
Cool. I multiplied both sides by x to the x. When I multiply this side by x to the x, right, this just becomes 1.
Okay.
So I just have 1 times dy over dx, which is just dy over dx. Cool. When I multiply this side by x to the x, right, I get x to the x times 1, which is x to the x, plus ln x times x to the x, which is x to the x times ln x.
Okay.
Right? So I just multiplied both sides by x to the x and simplified.
Okay.
Cool?
Yeah.
So then we get dy over dx equals this. So what does that tell us about the derivative?
That is the derivative.
Exactly.
Cool.
So the natural logarithm comes up a lot. Because it's such a convenient derivative, like it's 1 over x and e to the x is its own derivative. The idea that the derivatives are so simple makes them appear a lot in other derivative rules. So you see how the kind of processes we were doing today, where we took logarithms, used implicit differentiation, all these techniques, they can be used to find the derivatives of weird functions, any function, etc.
Yeah.
So I'm just trying to show you that with the things we learned today, you can find the derivatives of any function no matter how weird. you have the tools to figure out the derivative of this function, even though it seems like you wouldn't. You just have to use log properties, implicit differentiation, etc.
Okay, can we definitely do some practice tomorrow?
Yeah, let's do
I would say prioritizing, because I think I need a little bit more practice on like implicit differentiation.
Yeah. Let's walk through. I think that's a good idea.
Being able to do that myself.
Yes, let's walk through some implicit. I think that's a good idea. If you're curious, I'm not going to force you to do it. So don't feel pressured. It's only if you're curious.
You better shout out three blue, one brown.
I would recommend you watch him, but I'm actually just going to shout out myself.
Don't bet.
There's a video I made that talks about the derivatives of I called it the derivatives of lesser known functions via implicit differentiation. I kind of do the same.
I'm gonna take a picture of that. I'm gonna watch that.
I did the same thing that we did with x to the x, and I used it to find the derivative of like x to the g of x and g of x to the x. So like x squared plus 1 to the x, like the derivative of that function. So
cool.
If you watch this, I promise you'll know the derivative of every function. This is, I think, the last kind of function we have to deal with. But like yet again, you don't have to watch it because it's literally just the same thing we did with x to the x. It's the exact same process. But only if you're curious, that's there, and you would understand it.
Okay, perfect.
And if you're also curious about integrals and stuff, you would know how to. You would be able to watch this video now, I think. But that's only if you're interested, because we're going to be covering it later, so don't worry about it.
Okay, I'll let the course run itself, and I'll let you do it.
Good. And also, if you need a refresher on the chain rule, stuff like that, that's here.
Cool. Okay, yeah, I'll keep that in mind, just like in case I need any like refreshers or anything. I know that I can go to that.
Yeah. Oh, look at this. This talks about Euler's formula, like we were talking about today. I forgot I made all these videos like 7 months ago and stuff. But, yeah. All right. So that's it for today. The next slide just says that's all for today. And tomorrow we begin Unit 4 of the Calculus textbook, which discusses application of derivatives. We're going to do some practice problems tomorrow, but just for the YouTubers, the next video will be the beginning of Unit 4. So see you guys then.